Welcome to our next video. This one is on using ratio tables to help us compare our rates and ratios together. So go ahead and get your notes page set up. Our title is Ratio Tables. Our learning standard is 6RP3. And then our I can statement is I can use a ratio table to help find equivalent ratios. So when you're ready, go ahead, hit play, and we'll go on to the next one.
Today's vocabulary words, you need to space this out so you have room to write the definition, are equivalent ratios and ratio tables. So, starting with our first definition, an equivalent ratio is ratios that express the same relationship between two quantities. They're very similar to equivalent fractions, so what are you writing?
Just writing equal.
Oh! So you'll get the hang of it really quickly. Whatever you do to the top, you do to the bottom. But we're going to be using those equivalent ratios throughout our tables today. Ratio tables are something.
I was trying to figure out if my E was backwards or not. It was bothering me because it was so bad.
It does look like a 2-year-old. A table filled with pairs of numbers that have the same ratio. So a table is just going to help us organize our equivalent ratios so that we can go back and forth between quantities.
All right, we're going to do a handful of examples. For each one, you do need to write down the problem itself.
So sorry, but you have to understand it.
So write down those two sentences and then create your table, and then we're going to talk about it together here in just a moment. All right, so this one says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. We want to know if we want to make 5 cups, how much yellow food coloring do we need to go with the icing? So it's just like our equivalent ratios. You're trying to look for that pattern between two of the numbers. So think about what would I do to a 1 to get to a 5? Well, hopefully multiplying times 5 comes to mind. Whatever you do down here, well, they could have added 4. I'm just making sure they're focused on multiplying. So we need to do the same thing up here. 6 times 5 is 30. So I would need 30 drops of yellow food coloring if I wanted 5 cups of icing to keep it in the same ratio. We do want to see this written in terms of what did you multiply or divide by as you're converting between your ratios. You're laughing at me a lot today.
Oh, I love Joey Chestnut. 4th of July. Do you ever watch it? ESPN?
Yes.
We should watch it in class.
And we're going to watch it in class next week.
All right. In a recent year, Joey Chestnut won a hot dog eating contest by eating 66 hot dogs in 12 minutes. I know, completely disgusting, but he does it. If he ate at a constant rate, determine how many hot dogs he ate every 2 minutes. So set up your table, set up your problem. Here we go. So he ate 66 hot dogs in 12 minutes. And I know you can get from 12 to 2 minutes, but the ratio table helps us organize more than one equivalent ratio. So yes, you absolutely have to fill in both parts of the chart. So you need to find a factor that you can go in between 12 and 2. So we can divide by, what do you want to do, 4?
Okay.
No, that's not going to work.
What are you talking about? All right, she's going to divide by 3 and get
Yes,
4.
That's what I meant.
Because a 4 can very easily be divided by 2 to get to a 2. So it's kind of, how do we make a step in between to help us get to our 2?
All right, sorry.
All right. So
whatever you do to the bottom, you do to the top. So 66 divided by 3 is 22. And 22 divided by 2 is 11. So he eats 11 hot dogs in 2 minutes. Think about that. Could we multiply and go larger and then divide?
All right, so I'm going to do the same one again.
Sure, we can.
We're going to get the same answer, but just to show you that you can do it in different ways. We don't have to divide by 3 and go to a 4. You can find another way to get there. Mrs. King thinks I could multiply times 2. That gives me 24. So I do the same thing up here.
I don't know why we want to do that, but whatever.
You're the one who said it. So I get 132.
So it's one
To get from 24 down to 2, I would divide by 12. I do the same thing up here. 132 divided by 12 indeed is 11. So there are a variety of different ways to get there.
Divide by 6.
You can divide by 6. You can divide by 2. So I could go down to a 6 and then down to, well, you said.
I know, yeah, I'm off today.
So I divide by 2 and then I divide by 3. Same thing. We're all going to get to the same answer. We just want to see what can you come up with for that step in between. All right, your turn.
Yeah, since I did so well. A patient receives 1 liter of IV fluids every 8 hours. At this rate, find out how many hours it will take to receive 4 liters of IV fluids. This time we are filling in the table on the bottom and we have information on the top. So we have to do that middle step. How can we get from 1 to 4 and make a jump in the middle? So let's multiply top and bottom by 2, because 2 is a factor of 4. So 1 times 2 is 2, and 8 times 2 is 16. How do I get from 2 to 4? Oh, Mackenzie says times 2, and 16 times 2 then would be 32. So it's 4 liters of IV fluids in 32 hours.
All right. One last problem. This one's a little bit tougher, so we saved it for last. It says that on a bike trip across Illinois, Dudley notes that he covers 280 miles every 6 days. If he continues at this rate, use a ratio table to determine how far he would go in 9 days. So unlike some of the other problems, there's not a quick way to go from 6 to 9, so you can't even cheat on this one. So we need to find a step in between. So you got a couple options. The one that comes to mind is I can turn a 6 into a 3, and then I know a 3 can very easily turn into a 9. So to get from 6 to 3, I divided by 2, so I'm going to do the same thing up here. 280 divided by 2 is 140. Now I have to go from a 3 up to a 9. That means I multiplied times 3. So I could do the same thing here. 140 times 3 is 420 miles. So in 9 days he would go a total of 420 miles. Maybe you thought of going up to 18.
Or to 36.
Or up to 36. And then back down to 9. Doesn't matter what you used. Just come up with something that helps you transition from a 6 to something that then makes it easier to get to your 9 as your final answer.
Whatever you do at the bottom, you do to the top.
Treat them equally. We'll practice this more tomorrow in class.